The Umatic format was launched by Sony in the late 1960s and was primarily intended, or thought the market at the time was going to be educational and industrial and perhaps the high-end domestic market. The format is based on 3/4 inch tape. It at the time came in two popular cassette sizes, 20 minutes and 60 minutes. And the tape ran at approximately 9.5 centimeters a second. It's a color under system, very, very similar to the well-known VHS system. However, it's a very robust format, and broadcasters very quickly became interested in it. And in the late 70s, the BBC began to take an interest in this particular format, primarily for news gathering. They did a trial period, and after negotiations with the staff involved, they introduced a pilot, and it very quickly took off. To give an example of how the format took off, the BBC's Holings show four compilation tapes held for 1981, 1,000 for 1982, and a peak was reached in 1986-87 where we hold 8,000 tapes. And this is purely for news stories, current affairs, and other departments like regional and other religious programs also took Umatic to their heart. Its decline was fairly quick as well, because if we look at our holdings in the library for the late 80s, we find that in 1990 we only have about 500 Umatic tapes. So Beta SP very, very quickly took over from Umatic. Throughout the life of the format, development continued, and eventually three variants were available. There was the original low band, the high band came along, high band so called because the carrier frequencies were shifted up, which gave a higher resolution from about 240 lines up to about 300. And then later on the SP version came along, which took benefits from the various tape formulations which were then available, for example Chrome. The carrier frequencies were also increased as well at that time. The BBC's holdings tend to be mainly high band, although the other variants are available as well. The formats chosen for our preservation of Umatic was at the time DVC Pro and DVD. The bandwidth lent itself very well to those formats. News changed their format to DV Cam, so we also changed to DV Cam, but we retained the MPEG version recorded to DVD. During the pilot, we did experiments to decide the level of compression we would use for the DVD copy. We eventually came down that we would transfer at the highest bitrate possible. DVD allowed us to go to 22 megabits. So taking off the overheads, 320 kilobits for the audio, we ended up with 18.6 megabits for the picture. Because of the massive holdings of Umatic tapes in the library, and to preserve these tapes in a reasonable span of time, 3 transfer suites were built. The 3 edit suites are very similar. The only difference really is in their complement of Umatic machines. And although they may have the same name of BVU 800, the characteristics of each one will be slightly different. As the head wears, it will handle tapes in a slightly different way. And this is useful because if a tape we feel doesn't play in one machine, we can then go into another suite and play it in that suite. And we can transfer them from one suite to another via a local area network. The Umatic cassettes are ordered up by our intake department and delivered directly to the transfer suites. We have no idea when we take the cassette out of its box as to what the problems might be or what we might encounter. All we have is a piece of paper telling us roughly what might be on the tape, and even then we can't trust that. We take the tape from the cassette box and pop it in the machine. Usually everything is fine, but just occasionally there's a bang and the tape is broken. This means we have to take the cassette, take it apart and use an editing block and stick the tape back onto its leader or join it together again. There may be damage on the tape. Even the emulsion may have dropped off, which causes problems in that halfway through the tape the machine sees a clear piece of tape and then stops. It might be very, very dirty. Numerous head clogs. It may be so sticky it actually won't pull out of the cassette. These are factors which are totally unknown until we pop the tape into the machine. When the format was first introduced, it was never envisaged that the covers would need to come off. It was new format, new tapes, and everything would work fine. But many years later, of course, that we come to try to preserve these old tapes, which have sat in our library for many years, degrading, gathering dust. We find, unfortunately, that we have to remove the covers to clean various parts of the mechanism, in particular the moving video heads and the various audio stacks and control stack. So we have to take the covers off and clean the heads quite regularly. In fact, we do it at least every morning and very often between tape replays. We have a pair of heads here, which is the flying erase head and replay record head, which I'm cleaning now. Vital that this up and down action should not be carried out, otherwise the heads will break. And we go around to the other pair of heads. And you can see the amount of dirt I've got off there. A problem that we do find is that we get build-up of dirt and white powder on the audio stack, which occurs just after the exit guide here, with the tape leaving the video head drum. So we have to make sure that that's nice and clean. When the cassette is put into the machine, two problems can occur which involve recovery of the cassette and or tape. The first one is when the cassette is loaded, the lacing mechanisms withdraw the tape from the cassette and in a complicated manner lace the tape round the various heads. If the tape is sticky, the head drum can stall and you're left with the tape still in the machine, and the lacing mechanism can be in a fully laced mode or in a partially laced mode. You can't eject the tape, otherwise damage to the tape will occur. So the tape has to be removed with great care. So what I'm going to do now is very, very carefully take the tape off the guides here. And then I have to raise the cassette. To do that, there is a gear just on the side of the machine here, which we can turn around with my finger. Very slowly raising the cassette housing, being careful not to damage the tape. So that's removed the cassette. In order to get the mechanism into the right place, we can actually use this worm here, and by mechanically turning it, it's necessary to do this because the tape can get caught around these pins here, and you have to in order to produce the gaps to allow you to get the tape out, you have to move the lacing mechanism to provide the necessary space in which to work. It's a very slow, laborious process, but you can actually see the mechanism slowly moving as we turn the worm, and thus the lacing gear driving the lacing mechanism. Yeah, we produced a nice gap here, so we can now unthread the tape.